Hello class, this is the fifth video covering the Test 1 review for Math 145. We're going to start off with question number 24. It says the table below shows the life expectancy at birth of people born in the U.S. And question A says find the average rate of change from 1960 to 1980. Okay, and then part B says from 1980 to 2015. Right, so we're using these 2 points. So first thing you want to remember is what is average rate of change? Right, that's considered the slope. Right, average rate of change is equal to the slope, which is y2 minus y1 over x2 minus x1. So if you think about these points as a pair, right, you could think of the year as x and the years of life expectancy in years as y, right? Think of the 1960 as like X and the 69.9 as Y. All right, so we need to find 2 points and get the average rate of change, right? So for the first one, 1960 to 1980 would be 73.7 minus 69.9 for my Y's. And for my X's, which is in the denominator, 1980 minus 1960. When we do this calculation, you get 0.19, okay? So for question A, your answer is average rate of change, or the slope is 0.19. And then from 1980 to 2015, right, that's here and here, you're going to do the math, but now these are my new Y's. And it's going to look something like this, 78.8 minus 73.7, right? That's coming from here, over 2015 minus 1980, and you get 0.15. All right, so for part B, your slope or average rate of change is 0.15. So they're asking, does it represent a linear function? The table represents a function because each input has one output, but that's not what they're asking. They're asking, is it linear? Right, so yeah, we have a function, but is it linear? And the answer is no, it's not linear. Right, because our average rate of change is not constant. We have 2 different average rates of change, or 2 different slopes. So I would say the table is not linear because the slopes, right, or average rate of change are not constant. Right? The slopes are different. The average rate of change is different, right? If we had 0.19 and 0.19, we'd say, yeah, it's linear. Or if we had 0.15 and 0.15, we'd say, yes, it's linear. But because the slopes are different, because the average rate of change is not constant, we would say we do not have a linear function. All right, 25, matching. It says match the correct graph and equation of the description by writing the correct letter or number in the table at the bottom page. Okay, so you have a submarine. So right away, just think about this. Right, if this is my coordinate system, this is X and Y. Well, think of this as sea level at 0, right? So if I have a submarine, it can't be up here, right? Because I'd be above the water, right? So you know the submarine has to be somewhere down here below the surface, right? So initially it's 1,400 feet below sea level. So this would be like minus 1,400. And then it rises. So the submarine is going to go up. Okay. So when I look at my choices, I'm thinking letter L works. Right? Because I'm starting 1,400 feet below sea level and I'm rising 80 feet per minute. Okay. So letter L would be my equation. So let's write that in our box. Down here, you would write letter L. And our graph would be, okay, let's see. If this is 0, 0, my submarine starting here and rising. So graph 4 would be my answer down there. Okay? So the equation is letter L and graph is number 4. Right? Graph 4. Equation L. Let's take a look at the next one. And maybe I'll change my ink. to a different color. There we go. Submarine is still 1,400 feet below sea level, but this time it's descending. So it's going down. So the equation is going to be very similar to A, except instead of my slope going up being positive, my slope should be negative because it descends, right? So minus 1,400 feet, it looks like this equation down here would work, right? Letter J, right? I'm starting 1,400 feet below sea level and I'm descending, I'm going down, right? So this is letter J is my equation. Right, that's a J. And the graph, right, my submarine would still be below the water. Right, remember, up here is 0, 0. So submarine is below the water going down. So graph number 3 is what works. All right, so that's the submarine problems. What else do we have here? Letter C. All right, you put 1,400 in your desk and you leave it for several months. All right, so I'm trying to just think about what happens here, right? Here's my graph. This is time. And this is the amount of money in desk. So if I put 1,400 in it, all right, this would be 0, so 1,400 could be somewhere up here, right? So I put 1,400 in my desk and I leave it and nothing happens. Okay. So this would be y equals m, right? So the equation would be m, right? Because the money that's in the desk doesn't go up, it doesn't go down, it just sits there. So letter m is just y equals 1,400. It doesn't change, all right? And when I look at my graph, number 5, right, this could be 1,400. Doesn't go up, it doesn't go down. So graph number 5 would be my answer. Okay. Let me just clean this up because I have a lot of tick marks and things that we don't need. I can erase the submarine stuff. All right, part D. All right, so you owe your cousin 1,400. All right, so you borrow $80 per month. So not only do you owe your cousin $1,400, you continue to borrow more money. So the amount that you owe is going to increase, right? So let's draw a new graph here. Right, this is time, and you owe 1,400, and you keep borrowing money, the amount you owe is going to increase. So letter D corresponds to graph number 1 and letter K. Right? You borrow 1,400 and then you keep borrowing another 80. Right? So the amount you owe is going to keep increasing. So for D, we're going to put in letter K for the equation and number 1 for the graph. Right? I owe 1,400, and then if I keep borrowing $80, the amount I owe is going to increase, right? So that's graph number 1. Almost done. And then the last one, letter E, you owe 1,400, but now you're paying it back. So the amount you owe is actually going to decrease. Right? The amount you owe would actually decrease as you pay $80 back every month. That's graph number 2. And letter N. Right? Right? Graph number 2, you originally owe 1,400, but now you're paying it back, so the amount's going down. Letter N, in terms of the equation, is you borrow 1,400, but every month it goes down by $80. Okay? So N and 2. Right, and number 2. All right, so that handles question number 25. What else do we have? All right, question 26, we have regression. I think I want to do a new video for this because this is going to take a bit of time. So I'm going to stop here, And shortly I'll post another video to cover question 26, 27, 28, and so on. Thank you for watching.